Hey guys, this is Notes 89. So today our goal is going to be to solve still our quadratic equations using the quadratic formula, which is our last idea from the last notes. But today we're going to deal with what happens when we have a negative and a square root. So remember guys that we have now this definition of an imaginary number. So whenever you have a negative and a square root, you can take that out as an I and then just kind of go from there in the same way you have been doing so far. So with that, let's go ahead and solve example A. In this case, this is already in standard form, so I can identify A is 1, B is 3, and C is 9. So I'm going to find the discriminant first. So remember, it's b squared minus 4ac. I'm going to kind of use extra space here, so sorry about that. So in this case, b squared, b is 3, so b is 3, so 3 goes in there. So 3 squared. Minus 4 times a is 1, so 1 goes here. And then times c is 9, so 9 goes there. Again, at this point you're going to compute it and get out a number, so get out a calculator or do it in your head. So 3 squared here is 9, and then negative 4 times 1 is negative 4, and then times 9 there is negative 36. So this is going to be negative 36. And then 9 minus 36 is negative 27. So with this being my discriminant, I now know that I'm going to have no real solutions, or today's note, I'm going to have two complex solutions, which means I'm going to have I in my answer. So with that, let's use the formula. Remember, x equals negative b plus or minus the square root of the discriminant that we just found before, so this will just fill in directly into the square root. So I'll just put this in directly here as minus 27. And it's going to be all over 2 times a. So just repeat the formula. X equals negative b plus or minus the square root of b squared minus 4ac, or the discriminant, which we just found before, all over 2 times a. So to finish this question, let's go ahead and plug in our two other values. Negative b. So again, b here is 3. So I'll put a 3 in here, and then all over 2 times a being 1 in this case. And now I'm going to compute this. So I get negative 3, so x equals negative 3 plus or minus. Now, in this question, when you have a negative and a square root, we're going to simplify that out as an I. So this would come out as an I, and then 27, we can think of that as basically, it's going to be 3 times 9. Now notice how 27 is 3 times 9, so I can take out the perfect square here. So if you think of it in these terms, the square root of 9 is equal to 3, so I can simplify this out a little bit more and take out a 3. So let me kind of make some space here. So I'll put the 3, then the I for the negative sign, and I'm left with, if I simplify radical 9 out, this radical 3 is still in the radical. Then all over 2 times 1 is 2. So this will be the answer for this first example. Again, it might look weird, but to think about the steps from the last page of notes, we're just solving a quadratic with the quadratic formula, which is messy, but it's powerful because it always works, regardless of how ugly the work may be. If you like, pause the video, try example B, and when you come back, you can check your work. Alright guys, so here's example B. So again, this is in standard form. A is 1, B is 2, C is 8. I find my discriminant first to find that it's negative 28. Because it's a negative discriminant, I have no real solutions or two complex solutions, which means I have an I in the answer, or in the answers. When I use the quadratic formula, I get negative 2. Now notice how in this case, to simplify 28, here are all of its factor pairs, and 4 times 7, here's my perfect square. So this is a 2 by 2 square. So I can factor out a 2 from this square root out, and then the 7 stays in. So that's how I simplify square roots from before. Now in this case, notice how you have these three terms, this minus 2, this plus and minus 2, and then all over 2. When all three have the same factor, you can simplify a little bit more and take out, in this case, the negative 2 they share in common. So I can do this as my final answer. So I can reduce the 2 out of all the terms, and then my answer here is going to be x equals negative 1 plus or minus I radical 7. Again, looks a little bit weird, but just follow the process and try to compute to the final simplified version of the answer. Again, pause the video if you like, try example C, and then if not, I'll come back and I'll explain that one fully. Okay, so example C. So in this case, notice how this is not in standard form to begin with. So my first job before I do anything else is to move this negative 20 back to the left with all the other terms. So to move this over, I'm going to have to undo it by adding 20 to both sides. Now 20 minus 20 gives me the 0 that I need. So now I have x squared minus 5x, and then now this is a plus 20. So from here, I now have a is 1, b is negative 5, and c is 20. So now I'm going to find my discriminant. I'm going to use this space here to my left. B squared minus 4ac. So again, b is negative 5, so that goes here. And then a is 1, so that goes there. And then c is 20, so that goes there. Negative 5 squared is 25. And then here, multiplying these three together, I get negative 80. So 25 minus 80 is going to be negative 55. So there's my discriminant. So again, because it's a negative discriminant, I know that it's not factorable. And here again, I'm going to have two complex solutions. So I'm going to have an I in the answer. So now I use the formula. So x equals negative b plus or minus the square root of the discriminant, which we just found, all over 2 times a. Again, my discriminant, I just found it to be negative 55, so that goes in under the square root. And then it's negative b, so negative b, so b here is a negative 5, so I put a negative 5 in there. So I get a negative 5 in this case. And then all over 2 times a being 1, so 1 drops into that parentheses. So now I get negative times a negative is a positive 5. So I get 5 plus or minus. And then 55 can't simplify, but this negative will kick out as an I. Again, that's today's lesson. So I get an I out of that. The 55 stays in all over, again, 2 times 1 is 2. So here are my two solutions for this quadratic. Again, guys, at this point, that's the notes. So everything else below are going to be examples. I'll show you one more like I did with every step, and otherwise you can pause the video, try the other ones, and hit play as you wish to kind of see the answers to the other ones. Good luck, guys. Alright, guys, so one point I do want to make with these examples now is notice how the way that the questions are phrased, they have different terminology. So, for example, in example D it says solve, E says find the roots, F says find the zeros of the function, G says find the x-intercepts. These are all synonyms of each other, so I can ask the same question in these different ways, and I just really want you to solve the quadratic in these notes using the quadratic formula. After today's notes, you're going to have choice as to which technique you want to use, depending on the question and what you feel more comfortable with. But for these notes, let's practice the quadratic formula just to get better with that. So example D. This is already in standard form, so a equals to 4, b is 7, c is negative 2. So I'll find the discriminant, b squared minus 4ac, and I'll work it out. So b is 7 minus 4, a is 4, and c is negative 2. Again, this is going to be just a numerical value, so get a calculator or just work it out step by step. So here, 7 squared is 49. And then multiplying negative 4 times negative 2 is going to be a positive. And then basically 16 times 2 is 32, so plus 32. And I can add these together to get 81. So here I found my discriminant. Now remember, when I find the discriminant, it gives me two facts about my quadratic. One, can I factor it? In this case I can because it's a perfect square. And second, how many solutions will I have? It being positive, I'm going to have two real solutions. So here I don't expect to have any i's in my answer or in my work. Okay, so now we use the formula. X equals negative b plus or minus the square root of the discriminant, which we just found to be 81, all over 2 times a. So we fill it in. X equals negative b, b is 7, and then plus or minus the square root of the discriminant all over 2 times a is 4, so now I can work it out. So here I get negative 7, and in this case it's plus or minus. We know this one, the square root of 81 is 9, so that's convenient for us. And then on the denominator, 2 times 4 is 8. So in this example I do have 2 solutions, and I here, because it's a plus and minus and everything is a nice number, they're all integers, I can go ahead and separate the plus and minus to get 2 numerical answers. So I can say negative 7 plus 9 over 8, and then comma negative 7 minus 9 over 8. So then I get here 9 minus 7 is 2 over 8, which would be 1/4. And then minus 7 minus 9 is negative 16 over 8, which is negative 2. So this question, when I work it all the way down, I get 2 solutions of 1/4 and negative 2. Guys, again, to put it all together, if you went on Desmos and you graph this quadratic, you would expect to have a very skinny smiley face with x-intercepts at 1/4 and negative 2. Okay, at this point, you can pause the video, and when you come back each time, you can check each next example and find the responses. Alright guys, here is example E. So again here, I found the discriminant first. It's negative 7, so I expect to have I in my answer. I'm going to have 2 complex solutions. Using the quadratic formula, I get a positive 3 plus or minus. This comes out as an I, radical 7, all over 2. So there's my response. Again, pause it and try F. Alright guys, example F. Notice how this is not in standard form, so I first move the minus 9 to the left with the plus 9. Now x squared plus 9 is a quadratic, but it's missing your bx term. So if I wrote it fully out for you here in the blue, a is 1, b is 0, and c is 9. I found the discriminant to be negative 36, so I use a quadratic formula, and again going through all my steps here in this case, negative 36 will come out of a square root as a 6i. So when I separate the plus and the minus, I do end up getting 3i and minus 3i. Again, pause again and try G. Alright guys, example G. So again, in this example, it's not in standard form to begin with. So I move the 3 over with the negative 3. Then I have a is 2, b is 5, c is negative 3. I find my discriminant to be 49. Again, in this case, I know it's factorable because it's a perfect square, and I'm going to have 2 real solutions. So I use the quadratic formula again here, and I get negative 5 plus or minus the square root of 49 is 7 all over 4. And again, in this case, I can separate my plus and minus into the plus scenario and the minus scenario, and I can find my 2 answers down here as 1/2 and negative 3. Again, pause and try the next example. Alright guys, example H. So again, this is in standard form, so A, B, and C are identified. I find my discriminant to be 56, so I know I'm going to have 2 real solutions, so no I in this example. When I use the formula, notice how in this case I do end up with the square root of 56. Listing all the factor pairs, the biggest perfect square that I have is 4. That's a 2 by 2 square. So I know I can factor out the square root of 56, so this can factor out as, sorry about the quick changing here, as 2 square root of 14. Again, because the square root of 4 is 2, that comes out of the square root, and the 14 sits in. So now I end up having in the formula negative 4 plus or minus 2 radical 14 all over, and then 2 times 2 down here is 4. And then at this point, notice how all 3 of my terms, this negative 4, this 2 rad 14, and this 4, all share a 2 in common. So I can do one more thing here. I can factor out a 2 out of all of these and get a final response, a simplified response of x equals to negative 2 plus or minus the square root of 14 all over 2. And that would be my response for example H. Again, pause it again and please try I. Alright guys, example I. So I wrote kind of big here, sorry for spilling off the page a little bit. But here are my A, B, and C values. Found the discriminant. Again, this is a positive 121, so that's a perfect square. So this is factorable if I choose to use this later on. And I'm going to have 2 real solutions. Using the formula, this becomes a positive 9. Radical 121 comes out as 11. And again, in this case, because I can simplify this a little bit more, I can just get numerical answers for my solutions. I can separate the plus and minus. and I can compute to be x equals 5 and x equals negative 1/2. Guys, the last two examples, J and K, are a little bit harder, and again, in fact, this is all kind of messy, so take your time with it. It just takes practice, but once you get used to the steps and the procedures, you kind of catch on to how this flows every time. So J and K are a little bit more tricky. They'll make more sense next week or in the next notes when we have different techniques to choose. But for today, we'll use a formula just to kind of force that and get more practice. So I'm going to show you J here in a second, step by step. So notice how, for example, J, this is not in standard form. If I was going to use the quadratic formula here, what I would do is I'd have to expand out x minus 5 quantity squared. Just for practice, I'm going to do it on this first one because we'll need it on the next one over. So in this case, remember from before using the box method, all this means is I have two of these. So using the box method, I have x minus 5 and times x minus 5. So x times x is x squared, x times negative 5 is negative 5x, x times negative 5 is negative 5x, and then negative 5 times negative 5 is positive 25. So I can do this pretty quickly, and this comes out as x squared. Notice then here, I get minus 5x minus 5x. That's going to be, they're like terms, so that's negative or minus 10x, then plus 25. So I've expanded this piece out in my equation, but this equals to 16. So if it's equal to 16, this is not standard form. At this point, I can now move this 16 back to the left by subtracting 16. And I get x squared minus 10x. And here 25 minus 16 is going to be plus 9 equals 0. So in this question, it has a harder setup, but I've now gotten my standard form of a, b, and c. So with that, I can now apply the quadratic formula in this example. So I'm going to first find my discriminant. I'll do it here on the side. So remember, it's b squared minus 4ac. So b is negative 10, a is 1, and c is 9. So I get 100 minus 36. That's going to be 64. That's nice. That's a perfect square, so it's just factorable, or I could, and I'm going to have two resolutions. But using the formula for today, x equals negative b plus or minus the square root of the discriminant all over 2a. In other words, x equals negative b is negative 10, so that goes there, negative 10, plus or minus the discriminant, which we found over on the left to be 64, all over 2 times a, which is 1. This becomes 10 plus or minus 8, because the square root of 64 just is 8, all over 2. Separating the plus and minus, it's 10 plus 8 over 2, comma 10 minus 8 over 2, which is going to be 18 over 2, which is 9. And then 10 minus 8 is going to be 2 over 2, which is 1. So in this case, I know it's really messy, and it'll get cleaner later. I find that x is 9 and 1. I found my two solutions. With that, again, these are harder. Let me just pause the video, catch your breath here, and I'm going to show you k, and then we're done for the week, guys. Alright guys, last one, example k. So in this case, I multiplied this out for you behind the scenes here. So we have 4x squared minus 4x plus 1 equals to x. So again, not standard form yet. If I subtract x to both sides, this would be 0, which is what I need, and I get 4x squared. Then here, minus 4x minus 1 more x is minus 5x plus 1. So now I have standard form of a, b, and c. So now I can find my discriminant. So b squared minus 4ac. So it's b is negative 5, a is 4, c is 1. So 25 minus 16 is going to be 9. So again, that's a nice discriminant. It's convenient. So to wrap this up, x equals negative b plus or minus the square root of the discriminant, which is found to be 9, all over 2 times a. So negative b, so negative 5. And then 2 times a on the bottom there, so I get that. So I end up getting, here this becomes positive 5, plus or minus 3 all over 8. And if I separate that, I end up getting 5 plus 3 over 8, 5 minus 3 over 8, which is going to be 8 over 8, which is 1. And then it's going to be comma 2 over 8, which is 1/4. So again, here I've solved this quadratic. It was a little bit inconvenient, but as you get better, guys, you'll see how these work, and you can work your way through all of them. Look, with that, this is the work for the week, so practice this a little bit. I know it's kind of long. Guys, again, we're going to minimize quizzes here. You now have your final exam being posted one question at a time. So take your time now for this week through Sunday to work on these 2 assignments and your final exam question number 1. If you have any questions or need help, please Google Classroom me or remind me or school loop me an email, and then we can figure this out. All right, guys, good luck. Take care.